to make sure it has one solution. But what is the problem with this method? What might go wrong? Yeah? Or when? Yeah. Yeah, but I mean, like, what is a disadvantage of this method? It's long is one disadvantage, although the next method I'm going to show you is longer. What's the other disadvantage?
Not flexible.
Yeah, how? What do you mean by not flexible?
You can only solve when two line meet in one point.
Oh, you're close, but you missed it. You missed it. The ball bounced around the hoop and then fell out. Sorry. Close though. Anyone else? No? The problem with the method in the last class is it only works for quadratics. It doesn't work for cubics or anything else. So we need a different method that can work for any type of problem. And that method is called the first principles method, which is what this lesson is. Yeah? Okay, so here's the idea. Nearly dy dx, yes. This is y, this is x, this is 1 point. And we want to find the tangent here. So what we do, let's just call this point here, that's x, and then here we'll call that f of x, because we'll make this graph y equals f of x. So this point here is x and f of x. Now we know that we need 2 points to find the tangent line. So what we'll do is we'll use a second point here, which is close. We'll call it x plus h. Well, you know, it's nearly there. And then this point here, that will be f x plus h. Yeah? Now, is this line a tangent? No, not a tangent. What's it called? What's it called? Do you remember its name? Secant, yeah. But it will be close. So it will do for the moment. So let's test what we can say here. We can say that the slope of the secant, which is roughly the slope of the tangent, but it's not exactly that, we'll say that's equal to m, which is equal to y2 minus y1 over x2 minus x1. And in my picture, I can see that's going to be fx plus h minus fx over x plus h minus x. In other words, that's going to be fx plus h minus fx over h. That's our first sort of result here. This is called the slope of the secant, and we don't use the letter m to represent this slope. We use the symbol delta y over delta x. This is the slope of the secant here, of this line. Let's use this formula with a particular example. Can I scroll down?
No.
Are we just waiting for Lee?
No.
Can I continue? Who said no originally? Oh, okay. Continue. No problem? Okay. Next, let's use this formula with an example. So, for example, let's take this quadratic, simply just y equals fx equals x squared. And let's take this point here, we'll say the point 1. So if it's 1 on the x, what's this value here? 1. Okay. Not that you really need to know that. Right, let's find the secant line here. So, using our formula, we have fx plus h minus fx all over h. In this case, it will be x plus h squared minus x squared over h. That's equal to x squared plus 2xh plus h squared, yeah, minus x squared over h. Nicely, the x squareds cancel. 2xh plus h squared, yeah, over h, which is 2x h over h, yeah, plus h squared over h, which is 2x plus h. Now actually we know what the x is. What's the x? At the start I said what it was actually. It's 1. So, at x equal to 1, this will be 2 plus h. That's the slope here. So this is, if actually, I'll be a little bit clearer. This is at x, and this one is at, oh, what am I saying? Oh. 2 plus h. This one is at x, and this one is at x equal to 1. So the way we write that is like this. This is delta y delta x, and this is delta y delta x. And does anybody know what I write differently? Yeah, but where do I put the 1? Like here? Where does the 1 go? Oh, there. No. You draw a line like this, and at the bottom of the line you say x equals 1. Yeah, so this means slope of secant at 1. And this one here is just at some x. Do you need me to zoom out? But we don't want the slope of the secant. We wanted the slope of the tangent. So let's see how we can get that now. We're nearly there. Can I go? No? Yes? Yes? Okay. Yeah. Yeah. Now, if we go back to the graph, the h represents a point which is near 1, just a little bit past it, and this makes 2 points here. But we don't want 2 points, we want 1 point. We don't want this, we don't want this, we don't even want this, we want exactly this. If you look at these 2 points, the h is the distance from here out to the second point. And likewise, here it is here, And likewise, there it is there. So in this case, what has happened to the h? It's become 0. So this is the idea. If we let h shrink to 0, then what will our answer be?
2.
It'll be 2. And this is the slope of the tangent. Not the secant, the tangent. And because it's the slope of the tangent and not the slope of the secant, we represent it with this symbol, dy dx. Bum, bum, bum. Some people already knew that though. So this represents the slope of the tangent. Tangent slope. Yeah. Okay?
Can you apply this even if you don't have education?
What do you mean? Oh yeah. Well, we have more to talk about this, but this is just a basic idea. Okay, so just, can I scroll down now? Just to recap the difference here. The slope of the tangent is roughly equal to the slope of the secant. But if you want to know the exact answer, it's the secant, but when you make the h part shrink to 0. And the only reason we had the h, what was the reason we had the h to begin with? Well, to make 2 points.
Yeah.
That was the only reason we had the h in there. In other words, we had the h so we can make this formula. So putting these results together, we end up with this formula. dy dx equals f of x plus h minus f of x over h, with h going to 0. So this is a way to calculate the slope of the tangent, and it has the advantage of working not only for x squared, but for any type of problem. In fact, this is the definition of the slope of the tangent. And because the slope of the tangent is so important in maths, it has its own name. Slope of tangent. Does anyone know its name? That is the verb. Give me the noun. The differentiate? No. Nice try. Got that, Eric? You're reading that from the dictionary. Thank you. Derivative. Yes. You were close and you were... Derivative is what's this called. It's his name. Derivative. That's a very, very important word in maths. Okay? Really, really important word in maths. Because it's most of what maths is. Okay. Let's have a look at another example now. Can I scroll down? I'll give you a hard one to try, and then I'll do it. Using the same method I just showed you, find the derivative. Oh, well, just before you do, Actually, I just want to also say, there's another symbol used for this. You might see in books sometimes. Does anyone know the other symbol? What is it? What the heck is that? No. Thank you. F prime. Okay. Try this example. Find dy dx if y equals root x. Using first principles. In other words, using the formula and the method I just showed you. Because there are other ways to do it. That's not what I want. I want you to do it the way I showed you just now. Try this one and then I'll give you the answer. See what you can do. Why do you look shocked? Got an answer? My way? Is it right? What did you get? 1 over. I feel like there should be a 2 in there. Somewhere in there.
Root x over x.
That's still missing a 2. That's what she said. Is that what you got?
Yeah, you should be. Because I did.
I thought there was a 2 somewhere in the answer.
Two?
For the 10th time! 2! Yes!
Over 2?
I think so.
Oh yeah.
I thought so.
1 over 2 was that.
There we go. Now we're talking.
I just removed all of it. It's 8.
Now we're going to do it now, Lee. So, I mean, you can have a look if you want, but you're going to see it now. Eric, did you get an answer?
I got the answer from A. Don't know the process.
So how'd you get the answer? Huh? Derivative?
No.
Yeah, okay. Right, let's have a look. Can we look now? Yeah, guys? Yeah, okay. Right. Okay, let's get the secant first. So that's going to be fx plus h minus fx over h. That's going to be root x plus h, yeah, minus root x over h. So you're looking at this going, well, what can I do? What can I do to simplify this? What can I do to simplify? Yeah, you could multiply, yeah. You could multiply by root x plus h plus root x over the same thing. Let's see what happens. When you multiply the top, you'll get x plus h minus x. Now, I skipped the step in the middle. All I'm doing in my head is I'm doing this by this by this one, and this one. And in the end, you get this. And on the bottom, in the end, you'll get this. H times, well, no different really. On the top, the x's cancel. Plus, thank you. On the top, the x's cancel. So you're left with plus h, a positive h, over h, root x plus h, plus root x. Now, this is nice because they cancel. So that's 1 over root x plus h plus root x. Now, that's the secant. But I want the tangent, so now I need to make h 0. 1 over root x plus root x. 1 over 2 root x. And this is the answer. We don't know the x. If we knew the x, we can have an exact number answer. This is the answer though. Yeah. 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 What? No. What's the problem? Okay. Did you write this down? dy dx is what now? What? Oh, that's a ugly delta that morphed into a d. Totally bad delta. Okay, can I just have a look at the book there, please, Sammy? Thank you. I just want to see which ones are good for you to do. Here you go. Okay, guys. So just listen about the exam. Okay, so just so you're clear what's happening with the exam, just make sure you're 100% clear. You have, your semester 1 exam and your semester 2 exam. So this exam is written by DIFC. This exam is written by NCUK. This one here, this year, will be written by John. Now this one here is written by some person who works for NCUK. Different people write different styles of exams. You know this, a different person, the exam will be a little bit different. Most of the time, the exam does not have this lesson in it. Except one year, it did have it. And this was the year when a person by the name of Stepan? Something? That's when this person here wrote the exam. Because he seems to like to put in hard questions. Some guy named Stefan, I don't know. Anyways, even though Joan is writing the exam, I think she likes this question now. So I'm telling you this because it means I'm not writing Stefan is not writing the exam, your final exam this year, which means you probably won't get this question in the final exam. Probably. But you might get it in the semester 1 exam. And if you do get it in the semester 1 exam, it won't be too hard. So I just need you to do question number 2 in the book. Okay? No, I want you to do one of each type. So what is the first one that's a constant? I think it's 2A, is it? It's just 5. What's the first one that's linear? No linears? Okay, what's the first one that's quadratic then? 2B?
Yeah, 2B.
Wait, 2x sounds like a linear.
Minus 2x squared.
Okay, that's better. And is there a cubic?
B.
Nice. And is there anything after cubic?
Yep, in the x4. Is the x.
Nah, that's okay. And is there anything that have roots in it? No. Okay.
What?
If you can do these, it's enough for the exam. For this one, okay? So I'd like you to try these now.
Will the formula is given? The delta 1 over delta x.
I believe not, but I need to look. The formula book is on Moodle. You can check if it's in it. But from my memory, I don't remember seeing it there. Yes?
So this part is like a base of a cartoon. So if our engineering students learn about cartoon in the semester 2, it's going to be broke in final.
Not really, because what will happen soon is we'll use this formula to prove certain rules, and then we'll use those rules in the future. For vectors, our maths and our vectors are not difficult enough to require a delta x. At university it will be, but not for this level. Here's the first one.
It's on 0.
Yeah, but think about it. Think about it logically. It should be 0 because the graph 5 is a horizontal line, and a tangent is the line itself, which is horizontal, so it has no slope. Technically, it's a bit of a weird tangent because it meets the curve everywhere. Please, no Deadpool references in class, please. It's not even Deadpool? But what the heck is that face then? Is it Deadpool? It's not Deadpool, then what is it?
It's a shock face.
Yeah, Deadpool. Right, I'm ignoring you now.
Oh, this is funny.
Is it the tree of them? The tree? Finished? Too easy? Do you want me to give you a hard one? No. No, from my mind. Yeah. No, just her. Yeah, but prove it. Not good enough, not good enough. Yeah, prove it. Thank you. Anybody else finish these three?
Yes.
Now, Sean,
Yeah.
did you do it my way? Using the H?
Yes.
Yes, good.
I choose one.
Choose one.
Yeah.
Bruce, Chew, Jerry, what are you doing?
How about the question?
Yeah, how about that question?
It's fine.
It's fine, it's good. That's good. Are you finished? Okay, working together?
Yes.
For the people who are finished, you could try this one if you like. Yeah, try it.
Try one.
Find the derivative. Go.
But if we put
What did you say? Okay, let's have a look. Guys, for people who are curious, let's have a look at this one, okay? Delta y delta x equals ex plus h minus ex over h. Yeah? Okay, so that is ex eh minus ex over h. So that is ex bracket eh over that. Yeah. Now the question is, what happens when h goes to 0? Well, if you look at this, you'll get 1 minus 1
Yes.
over 0, which is 0 over 0, which is not 0. No value. Now this is the problem. It has no value. So how can we find the value? Well, let's just remember what h is.
We can find solution.
Yeah, we can. We can estimate the value. Remember, EH minus 1 over H, that's just equal to me saying E, a small number, minus 1 over the same small number. So on your calculator, if you type in E 0.0001 minus 1 over 0.0001, you don't get 0, you don't get infinity, you get a number. And you'll get about 1. So what's happening here is this piece actually becomes 1 if the h is small enough. So that's all gone, and you're left with just EX then. Yeah? BW? Yeah?
So if we say the limit h goes to 0,
Yeah.
that's what we're going to write.
Yeah. Yeah. But you might be thinking, how can I know it's 1? Maybe it's not exactly 1. Well, there is another idea that you can use. If the h is small, then e power h is roughly equal to 1 plus h. And you can check this on your calculator. If you type in e 0.1, you should roughly get 1.1. Or if you type in e 0.01, you should roughly get 1.01. So you know here that because this is small, you can say it's equal to 1 plus h minus 1 over h. Cancel, 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 cancel. So that's another way to think about it. Because you know h is small. So because you know that, you can do this. Okay, that was a hard example, way too hard for the exam. In the exam, the most difficult one they should give you is a cubic, x cubed. Yeah. In the exam, Bruce. Bruce? You heard, okay. Take a break for 5 minutes. Well, enough time for me to get more coffee.